which we are doing is to connect a capacitor in the series of this transmission line. As you can see, we have connected only one single capacitor, so it comes into the series of this circuit, and this is the compensation. This is known as series compensation, in which the total impedance of this circuit now becomes Z is equal to R plus J times XL minus XC. So one capacitor comes into the series. Okay, so that overall impedance will get reduced. So this is known as series compensation. If you connect a capacitor across the load, then it is known as shunt compensation. So in series compensation, the overall impedance of the transmission line gets reduced. And for this series compensation, we have taken the readings. Now this is the capacitor. You can see this is the capacitor which we have connected. Please focus on capacitor. This is the capacitor which we have connected, and this is our artificial transmission line, and this is the circuit for the compensated line, and we have taken the reading for the similar uncompensated case at the receiving end. So we have done the measurement from the sending end in this case by first the open circuited and the short circuited case. So this is simple. First we have open circuited this receiving end, then we have short circuited. So this is the reading which we are getting. So as you can see that this is for which case? This voltage is what? 44 volts. This reading it is there when it is short circuited. It is short circuited receiving end. So for the short circuited case, I am verifying the reading. This is for 44 volt, and you can see this sending end current is 1 ampere, and the power is close to focus on the power scale, so it is close to 6.1 watt. So similarly, both these set of readings will also be repeated if you are going to put capacitor here and give supply at the receiving side, and you do measurement from the receiving end. Okay, so the same set of reading will get replaced. So we are not showing that in the video, but you can see that this for this line, whether you are putting the supply here or measuring here, or putting the supply here or measuring here, you will get the same results, because this is a reciprocal network. And why it is a reciprocal network? Because this is a linear circuit. This R, L and C constitutes a linear circuit, and if it is a linear circuit, that's why it is following the reciprocity theorem. And if it is following the reciprocity theorem, you need to show that by calculating the ABCD parameters, that AD minus BC is equal to 1, both in the case of compensated as well as uncompensated line. This expression should hold true. Okay, thank you.